Welcome. In this session, we are going to work with an R package that's specifically developed for analysis of networks, in particular when networks are defined in terms of data sets for networks. So what you need to do is to use your R console, and there are two ways of installing this package. The first one is has to do with this command that says install packages. And let me display this again, install packages. And between parentheses, we specify the name of the package that we want to install. This package is going to be called iGraph. Okay, that and then I would hit enter here, and then there would be a process of finding this package if that's what we want to do. So you could install the package from command line in the console, and the name of the package is iGraph, and you would use this command install packages. Okay, that is one way. The other way is that you go to your menu, go on the top of your program. You have file. You probably cannot see that, but I'm kind of going file, edit, code, view, plots, session. This may be in a slightly different order if you're using a different version of RStudio with a different operating system, but surely in the drop that is called tools, under tools, you will find an option there to select that it says install packages. Okay, so you go under tools in your menu, choose tools, and then choose install packages. By doing so, we're going to be prompted to this window, and here you would type the name of the package that you want to install. In this case, this is called iGraph. Okay, and when you're ready, make sure this stays checked. Install dependencies. When you're ready to install, you hit this button that says install. Okay, let me do this. Hey, so one quick comment: if you are installing this from the command line, just note that the name of the package needs to be specified between quotes. Okay, so install that packages and between quotes iGraph, and then that would have the same effect as doing the installation from the other way which we discussed. So now we would be Now we would be ready to use this package, and once it's installed, you have to remember to use the command library, and then with the command library, type the name of the package, and then once we do that, then the package is ready to be used. Now we can use commands of iGraph, which is what we do next. So let me switch gears here to another document. And the thing to keep in mind is first you install the package iGraph, and then you have to specify library parentheses iGraph between the parentheses. So graphs are, as we had said, sets of vertices and edges. Here's a very specific example. We have vertices 1, 2, 3, and 4, and 5, and then we have some edges defined between those vertices. So if we are using R, then the first thing we want to do is to specify what we had just mentioned, library iGraph, and we will move next to define this specific example using iGraph. So once we invoke this package, this legend is very common, but this box here in this cell, this is what we want to do. So this letter G is a variable that we define under this library iGraph, and so we're going to say graph, and then there are two arguments here. Okay, there are two arguments. The first argument is this list, okay? And then there is a comma, and there is a second argument, n equals 5, specifying the number of vertices in this case. In this list, the space matter. This is sensitive to space. So we have 1, 2, space, 1, 3, space, 2, 3, space, and 3, 5. Space is indicating that this list contains the pairs of edges, okay? And once this is created, then the graph is going to be a data object, here in this case called G, and then there's the command V capital, this also case sensitive, capital V parenthesis G, that will give us a list of the vertices of this graph we just created with this command, and then E, capital E of G, will give a list of the edges, and you can see that the edges are listed with arrows, one going to 2, one going to 3, 2 going to 3, and so on. And so what you should do is to replicate this. You can be typing this in your R console right now. You also will have a copy of this document here. This is an HTML document that was generated using R Markdown. So you can replicate these steps. And so the next thing that we review in this document is that you can add nodes. In fact, you can add vertices and edges to a graph that already exists. Here's another example. The variable G1 is created first as an empty graph, and then you can add to that empty graph some vertices. So in this case, the command letters, if you're not familiar, letters is a built-in list in R. So here's the R console, and you can see that letters, um, we can see these are constants that are built in R, and this list contains the letters of the alphabet, right? So if we wanted to refer to a subset of this, we can say, I don't know, maybe 1 through 5, right? Or we could say something like 6 through 10 or something like that, and we can access portions of this list. So which is what happens in this example. So in this example, the vertices are defined as letters, a subset of 10 letters, and then there is another argument that's passed on here, and it's a color set to the color red. And it is because the vertices and the edges can also, under this iGraph package, can also contain things that are going to be referred as attributes. Okay, attributes are like, remember that example of the records of publications stored in Math SciNet. Each record would have several entries. Some were names of authors, some other entries included the name of the journal, publication year, the title of the article, and so on. So each when you define a graph, the graph could be multidimensional in the sense that each dimension may represent one of these entries or one of these pieces of information. So in this case, this graph is being created with colors on the vertices. Colors are attributes of the vertices. And also, you can add edges to this newly created graph, also passing and specifying an attribute of color for the edges. So if you type these lines of code, then you can type V of the vertices. You want to take a look at the vertices of G1, and by typing that, you will see the list of vertices. And then by typing E of G1, you will see a list of the edges. Another useful thing is to visualize graphs, represent them with drawings or um, plots of that display the circles and the lines. And so here we reconstruct this graph and the graph we talked about initially. And then here's the key. We use the command once the variable constructed with the command graph has been defined. Then when we use the command plot, we pass as an argument. The first argument would be that variable. And then these two options are these two arguments. One is vertex size and error edge arrow. You could ignore that. You could just have plot parentheses g, and that will give you a default plot. But these arguments will help the resolution with the resolution of this plot. So in this case, this would be the plot. You can see that there are some arrows, and it's because in general graphs or networks are going to be classified into either those networks in which the edges have direction and those in which they don't. When they do not, there is not a sense of direction, then the edges would not have arrows. Those are called undirected graphs or undirected networks. And then when there is a sense of direction, then they are called directed. Okay, so here's an example of how we build an undirected graph. The same edges between these five vertices. So we have that command in which we construct that graph. But now we reassign that variable, g, we reassign that under the command as that undirected. And this gives us a new definition of a graph. When we plot that graph, we can see that no errors appear. This is now a data structure that is storing information for a graph, which is undirected. So we mentioned that some graphs may store attributes, including color, for vertices and for edges. And it turns out that when that is the case and you plot such graph, then you automatically will get a display of the colors on the vertices and the colors on the edges, right? So you should make sure um, that you create a visualization for an example of a graph, for this example of the graph with colors on the vertices and colors on the edges. Another important thing is going to be reading data to manipulate, to analyze graphs. Okay, so here's where you can create your own example. Go ahead and create a file with extension txt. This would be a text file with two columns, such that the columns of that file would contain information on the edges. For example, we want to create this with 3 rows. The first row would be 1 space 2, the second row would be 2 space 3, next row would be 3 space 4, and you want to store that graph in a location, in a folder, in a directory, and you just have to make sure that you set the working directory. You can set the working directory. Let me show you how you do that. So you can set the working directory by going under session, and session has a drop down there in which you can specify choose working directory, and that by clicking choose working directory you will be able to browse and select a folder or a directory. Okay, so this is one way of setting the working directory. The other way is that you use the command and specify the path of that folder or that directory. Then by setting the appropriate path in the working directory using this command set wd working directory. After doing that, then you can use the command read graph and then pass as an argument the name of the file containing the file you created that contains the information on the list of edges. Okay, and by doing that, then you'll be creating this type of graph. It is also possible that you could create a graph not by reading from a file that is stored locally, but instead you could read information posted in a URL. So that's the other option. You would need to know what is the format in which the data defined in the graph is specified, but you should definitely try this example here with this data set for the so-called Karate Club, and you will create a visualization, something that looks like this.